In this question, we want to identify the minimum and maximum of each of these functions. We also want to figure out if the min or max are going to be a relative or absolute min or max. So to begin, let's just do a very quick review, and I'm going to use a rough sketch of a polynomial here to do that review. And the first thing we want to do is be able to identify what a minimum is. And a minimum is just going to be a U-shaped part of the graph. Okay, so are there any minimums here? Well, there's a minimum right here, right? There's a U-shape. And then there's going to be another minimum right here. That's another U-shape. Now, is it going to be relative or absolute? Well, absolute minimum means it's the absolute lowest part or most minimum part of our graph. And this one right here is going to be the lowest part of our graph, so that's going to be absolute min. And then this one right here, it's not the lowest part of our graph, but it's still a U-shape, so it's going to be a relative minimum. So that's all about the minimum. Our maximum is going to look like an upside down minimum, basically a U that was flipped. So is there any of those shapes here? And there is right here in the middle. It looks like we have a maximum. Now, is it going to be absolute or relative? Well, is it the highest part of our graph? No, because we've got our graph going upwards towards positive infinity, so this maximum right here is just going to be relative. So there's a very quick review on min and max. On to part A, we have f of x, and to help me out figure out what the min and max are, I'm going to use Desmos.com and graph this function. So here we are in Desmos, and I already graphed the function, and we want to figure out, is there any minimum here? Well, are there any U-shaped parts of this graph? And there is right here. Let me click that, so darken it. You have a U-shape right here, so this is going to be a minimum. Now, is it relative or is it going to be absolute? Well, you can see that our graph continues downwards here towards negative infinity, so it's not going to be our lowest part of the graph, so we're just going to call it a relative minimum. And I'm going to pull my graph over here, and it looks like right here we have a point called out. It's going to be a maximum because it looks like an upside down U, and it's going to be relative because it's not the absolute highest part of our graph. Okay. So back to my problem here, I have a very rough sketch of the polynomial, and we said that this was going to be our minimum, and then this up here is going to be our maximum, and it was a relative maximum. Okay, on to part B, we have g of x, and we want to do the same thing, so I'm going to go ahead and put this in Desmos.com and see what we get. So here is our graph, and let's look out for minimum. So here we have a U-shape right here, and that's going to be a minimum, but it's the lowest part of our graph, so we could call this an absolute minimum. And then looking up here, do we have any other U-shapes? Yeah, it's right here. We have a U-shape there, so that's going to be another minimum, but it's going to be a relative minimum because it's not the lowest part of our graph. That happened down here. And then what about maximum? Well, we have an upside down U, which happens up here. That's going to be a maximum, but as you can see, our graph continues to go higher and higher and higher here, so this maximum, it's not going to be the highest part of our graph. It's going to be in the shape of a maximum, so it's going to be just called a relative maximum. So back to our problem. Here is a rough sketch of our polynomial, and we said that this was a minimum right here, and we called it an absolute minimum. We said that there is another minimum right here, but this was going to be a relative minimum. And then we saw a maximum that happened right here, but it wasn't the highest part of our graph, so it was just a relative maximum. So there's all of our minimum and maximum for both of the polynomial functions.